Okay guys, here we are for lesson 7, and in this tutorial we are going to look at generics. And generics in Move really make Move a very powerful language and allow us flexibility in a way that other blockchain programming languages don't. So this is really exciting. So let's basically start a new project. So I'm just going to do Move New and call it Move 7, cd into Move 7, and then open up your favorite code editor. Cool, so I'm going to add a new file and call it generics.move inside my sources directory. And there it is, and I'm going to create a new module with the address 0x42 and call it generics. Cool. So what are generics, first and foremost? Well, we sometimes come across this problem with statically typed languages where we want a function or a method to accept multiple different types. And this can be called parametric polymorphism as well. It's found in other languages as parametric polymorphism. So we want our function to accept many different types of things, and the range of those things, or what those things are, we want to be specific about. This is to make our functions and our structs more generic and therefore cleaner and more powerful. For example, let's imagine the struct we had before, people, the people struct, and there's this field on it, age. Now let's imagine we have another struct called animal, and that has the same field, age. Okay, so then imagine we have a function which returns the amount of years left on average given the person's age. So for example, if someone's age was 80, maybe average years left might be something like 12, or if that person's age was 2, then it would be 80 years left or something like that. So but the function, when we specify the type, we would say the type to be person, but we also can apply that logic to type animal. The same logic can apply. So here is where we would want parametric polymorphism, basically generics, where we'd want to specify that it can be of type person or animal. And basically we often use generics when we are writing framework code, library code, so it's very useful in Move. Also, the vector itself, the vector type, can actually take in any type as a type parameter for the type of element. So we could have a vector of U8, we could have a vector of bools, we could have a vector of vectors as well. Let's just look at some examples. So first of all, let's write a generic struct. Let me disable Copilot. And let me also increase the font here. Okay, so we're going to write a generic struct. We're going to call it flexi. And then we have these angle brackets, which is a type parameter field. And basically here we say we have a field called x, and we say this is going to be of any type, right? Okay, so let's say we have a function now called new flexi, so it's going to create a new flexi, and we pass in parameter x of specifically of type U8, right? So that means this will return a flexi with this parameter of U8. So we're just going to return a flexi struct, and the field x is going to be the field x that we pass in. Okay, so let's write a test to test our code here. So function test new flexi. So what we're going to do is say let flexi. So this is the thing that's returned, and then we're going to say new flexi. We're going to call the function, and we're going to pass in a u8. So let's say the number 8. We're going to use std debug, and then if we go back to here, okay, cool. So that's flexi. I need to just import that move, so I can get it, I believe, from one of these ones. Not that one. Let's try this one. Yes, there it is. Move nursery. Now I'm going to go back to 7, which is here. Open up this one, 6J, paste. Cool. So, if you guys weren't sure what I did there, I just copied in the dependency, the move nursery dependency, so that we can use the debug print. So let's try our test. Move test, unbound function flex, typo there. Unbound, yes, it's not flex, it's flexi. Okay, cool. So basically it's complaining, saying that we need the drop ability here because we're not doing anything with this flexi struct. So as usual, we need to explicitly say that it has the drop ability. And then there we go. Our debug function is called and it prints out the flexi struct, which has the value 8. So here we declared a struct and we said it's going to have this field of any type. And then in the method here, where we actually return it, we specify a specific type. So the things between here can actually be anything. They don't have to be, it doesn't have to be any type. So by, it can be any name. So by default, when we're doing generics, we use the letter T to denote the generic, and we can also pass in multiple type parameters here. So here we have multiple type parameters, and then I can say something like this. We can add a new field and say this is going to be of type vector, and the vector will be field of T2. So I need to update my new flexi method, and we're going to say y is going to be of type bool. Let's just do that. Then this, I need to update the return to be bool here. And then what we do is y. Right, and then when we call our function down here, we're going to need to pass in some kind of vector. So first let's make the vector. So let y equals vector bool, and then I can just declare a vector right here: true, false, true, true. Okay. So now we can pass that vector that we just created in here as the argument. Now when we print flexi, we should see that array for the field y. Why is it doing that? Perhaps I need to do this. Unexpected let, and that's because we are missing, as usual, the semicolon. Invalid call, invalid parameter argument for parameter y. Oh, that's because we're saying bool here, but it's not a Boolean type, it's a vector of Booleans. So here. Cool. Unbound type T in current scope. That's because I forgot to rename there T1 and T2. Boom, it worked. So here we have our struct, and it has two things in it, a number X, and it has the vector true, false, true, true. So let's just test this now. Let's test how generic this can be. So here we've just said it can be any type. So let's try setting this to U8, and let's try setting this to a bool. And then this means that this will not be this means this will not be filled with booleans, but rather with integers. Right. And then y is y, that's fine. And this is just going to be a boolean value. So completely different types we're passing in for this struct. Okay, return flexi. We've not changed this return flexi or the struct. We've just changed the inputs for our method. It's just right here. I forgot to change this. So that's U8. Invalid return given bool. Yes, I forgot to change that. So no, that's fine. Boolean X, and then Y is vector. So what's it complaining about? I forgot to change the return type. So this would be bool and U8. And it worked. So this is an example of a generic struct. So saying these types are generic, but we can also have generic functions, which is pretty cool. So let's just say, let's just declare something very simple and call it generic func. And here, before the parameters, we put in our type parameter. So let's just call this can be given any name at all. So I'm going to call it hello type. And then we're going to pass in a parameter and a hello type. This parameter will be of type hello type. And it will return hello type as well. Cool. And all we're just going to do is return T. So let's try it out. Okay, so I'm going to pass in anything here. So let's pass in a number, 77. And for now, let me just remove this test so that it won't run. And then what we're going to do is just print the thing. So there it goes, printed 77, no problems. Now let's do something wild. Let's do a byte string. And there it is, no problems. And here's our byte string represented as a vector of U8 values, which is how the compiler interprets it. That's cool. So we've got a function here where I can pass in multiple types. It feels like, you know, that's crazy. That's so flexible, so dynamic. So let's do something else. Vector equals vector of type bool, and here we just say true, 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 false. And here we pass in our vec. Will this work? It works. So we can pass in a whole range of dynamic values here, which is great. Let's do something a little bit more real world. Let's have a function and call it new vector. New vector. And it's going to take in type parameter of any type, and we're going to call the parameter that we pass in arg and give it the type parameter of any type, and then this function is going to return a vector of our type parameter. So we are going to first do let vector equals vector, and then we use the vector method empty. And when we do empty, we have to specify the type. There's our type, our generic type, and then we call the function. So I'm not sure if we've used this empty method, but it gives us a new vector, and we need to pass in the type here. And this is absolutely valid because we're passing in our generic type. Now we can do something with our vector. We're going to do vector push back. And if you remember, when we push back, we need two things: a mutable reference to the vector and the thing that we want to push back. And then we are just going to simply return the vector. So here we're actually getting a function and creating this generic vector that we can fill with anything and then return. I mean, arguably quite powerful, especially doing this stuff on chain, like so easily, painlessly. It just feels almost too good to be true if you're used to programming in Solidity or so function test new vector, and just using in module unit tests. These are not obviously sufficient unit tests, but it's just great. So let vec equals what's it called, new vector, and we're going to pass in something here now. So let's pass in a string, vector. Okay, so debug print, and we want to print the vec, and I'm going to just remove this so that we don't run that, and let's run it. Unbound module alias vector. Oh yes, we're not importing vector, so let's import it from the standard library. Now let's try running it again. Yay! This is our string represented as a vector of U8s. Okay, let's try passing in something else. The number 11 creates a vector filled with 11. Let's try another type, true. And it creates a vector with a type true. So here you can see the power of generics. Very cool. This is just scratching the surface of generics, and we'll see how generics are used in the various frameworks such as Aptos and Sui, and we'll see the power of them very shortly. But it's just very cool that we can do all this stuff on chain and have this quite advanced, flexible type system. So I just wanted to introduce you to generics there. So thanks for watching. The next set of tutorials, we're actually going to start doing more cryptocurrency related things. So we're actually going to create a coin in Move, a fungible token in Move. So stay tuned for that. Alrighty, bye bye everyone.